company was established 20 years ago. I used to work for an asphalt company, and I was telling people I used to work in the polymer business, and before that in some other area in fuel cells. But in any case, I descended from what I call the crude, goes to the refinery and makes the fine products. So I descended from the top of the barrel to the bottom of the barrel, so to speak, where asphalt is at and all the interesting things are at. And what we, they can hear me. And what we're doing is going through really a tour de force of this. It's on very specific things. There'll be a lot of references in the back for you to see, and we can go on from there. But I want to give you a kind of walkthrough of this. So as I said, there's little Idaho, and there are acknowledgement. I could not do this with all the people. As I said, I stand on the shoulders of giants, so to speak. We have many contributors in here and research report. I should say that I give you this outline. I'll talk about things like transportation logistics, but very, very short, and the things that have come across. And I'll also talk about some asphalt additives. I'm not going in deep in that, just as a glimpse of what's going on. There are a lot of new things, all right? And every time you turn around, there's something new. That doesn't mean it's necessarily good. And we have the so-called balanced mix design. I was just at a webinar last week, and they're changing that. So pavement preservation, 13 years ago, we're involved in that. We had a mantra with that: get the right road, get the right people, and get the road done. And but really, the core of this talk, I think, is quality. We always talk about technical things, but the fingerprinting of the asphalt, it's been around, but there's some tools that are out there, new, necessary to this industry, and I want to talk a little bit about that at the end of the talk. And then I want to talk about a process innovation. When I talk about a process innovation, it means that it's increased productivity. And so I'll show some tools, technology that exists. If you put them together, they become a process innovation. They increase your productivity, okay? So it's not all about, there's lots of technologies. And so we have to put them into processes, so to speak. And then I'll have the conclusion on this. But before I say, asphalt is a very complex thing. We'll hear that. And but there's a mantra for the world is very complex, from politics to materials. But we have to make some assumptions, not some premise. And in asphalt, what do we say? And what you see, I think what comes from all this, and I was talking with Ken in the laboratory, I see all the equipment, all that went through and so forth and so on. It's asphalt starts out with the name ductile. It's ductile, flexible. But guess what? Like everything, it ages and it goes brittle. And what I see in the industry today is a struggle for finding, hey, where does this fail, right? At the beginning of Super Pave, it was rotting, right? Oh, there was rotting. Let's cure that, okay? So I think, so remember that premise. We start from ductile and we end up in brittle. And what all this stuff is all about, where can we catch this stuff? How can we measure it? What's the best way? And I see all the cracking tests out there. So it means that still searching, but it's a good thing. So let me talk about the traditional asphalt logistics. It's hot asphalt. And how we know about this? Well, I would say half the world use asphalt in a solid bag. Asphalt is coal. How many have seen asphalt coal in a bag, 1 metric ton? Anybody have seen that? Okay, in the Andes, South America, the 5 Andean country, Peru, Ecuador, Colombia, Bolivia, Chile, you get asphalt. It has to go up the road to build roads. I'll talk about specifically Peru. You have the coastal, which is hot. and you have the mountainous area, and then you have the jungle area, right, which is wet and so forth. You have some challenges. So you need to get asphalt up the road. But if it's modified, even worse, you get it up the road, 4,000 meters. One project I was involved, and then you need to keep the asphalt hot. Well, these B2 bags around the world are in South America. They're coming in and 1 metric tons. And I'll just give you an idea. Since we talk about carbon footprint, this is an opportunity to throw in the carbon footprint, right? So the hot asphalt, and these are some parameters, and you can look these up. There's a diesel factor and so forth. And you do, in the end, you do some calculations for 20 metric tons of CO2 emission, and you have 3,200, okay? Well, if the coal asphalt, it will be sitting until you're ready to use it, will be sitting in a storage, okay? So imagine you have to use tons and tons of this, okay? I know in this country, the refineries are close by and so forth, but you still keep them in a tank. I know where I worked in Idaho a few years ago, we used to buy in the winter and keep it, freeze it. If it was modified, it would freeze it, but you had to, heat it up slowly, so to speak. That's all I'm going to say about carbon footprint for the moment. So they come in one metric ton, and they also come in 300 kilograms bags. And so I want to share with you my concept. Since we talk about what I call the magic pyramid of pavement technology, because we're always talking about this. We don't, talking about one thing at a time and then another thing at a time, So I want to call it the triangle of rotting resistance, right? On one end, you have cracking resistance. Another end, you have fatigue resistance, which is load generated cracking, right? And of course, you have moisture. I want to compare this with the tire industry. A lot of the technologies came out of the tire industry, actually came like cross-link and polymer modified came out of the tire industry. I want to do a compare. I have down there the reduction footprint for this. That's what we have to do today. So the magic pyramid, the actual designing tires, they actually have a magic triangle of tire. And what's that all about? Well, it's about they needing to get the wet grip. They need to abrasion. So they have to balance three things all the time. And we used to sell into the polymer industry. They want this type of polymer, want this polymer but one thing affects good grip but not good abrasion and that kind of thing. So it's a kind of similar comparison, perhaps a little bit more complex here. We have cracking, rotting, moisture, resistance, and so the decisive factor here is asphalt. And what we've done, we have all kind of additives, that we have placed in those polymers, oligomers. We have RAM as the new definition of recycled asphalt materials, RAP and RAS, plastics, and sometimes we need to stand back. We're experimenting, but what is to be done? What do we, in the essence, the asphalt is a carbon material. It will take certain things it will not take. From a basic, unless the laws of physics have changed, then we need to discover what those laws would be. So let's move ahead here and see what we have here. So we have development of the last 40 years, and there was a definition of innovation from the beginning, and a lot of these things came out of the Federal Highway Administration. A lot of research that came out of this, and what I wanted to show you here is, if I can better up do it this way. So you see, we have a lot of proposal for innovation back then here. A lot of rheology. You knew a lot of that rheology imported from the polymer industry came into our industry. We had low temperatures consideration to consider, the redefinition of what low temperatures and the pavement, what you measuring at the pavement, and then polymer chemical modification. I want to say we always hear about polymer modification. Well, the chemical modification, when I refer to chemical modification, I'm referring to polyphosphoric acid, which is a short polymer that modifies the asphalt. And there are a lot of myths about polyphosphoric acid. The Asphalt Institute has a report out on that, right? And, you know, like everything is, as Ken and I were discussing, sometimes a good thing, you overdo the good thing, right? And you make a bad thing out of it. And we have some new parameters, and I'll discuss about these parameters very quickly, because a lot of things is, hey, what is this all about? And the moving ahead for progress, for the first time, pavement preservation, bridge preservation was incorporated into the legislation in this country and back then, okay? And so that got things moving. And we have a whole series of NCHRP work that goes along with this. And here are some of the details of that. We have the binders, you know, the other things that were done with the BBR. We'll talk a little bit about the delta TC. Everybody here, we have about the so-called R value.
To stand there and then focus on that one if you want to see you.
Okay, you can't see this?
No, but I can see it, but the people are online.
All right, they want to see this one.
No.
No?
No, they're able to see anyway.
Yeah.
The slide, but I think they cannot see you.
They cannot see me. I don't want to see you. They don't want to see me. Okay, so anyway, we have a series of projects, and what we're doing, what is new and where we're headed. Okay, so we have, and they're not necessarily in order. Okay, I should say the Glover roper reactor, I don't know if people know where this originally came from. Glover used to go to Peterson and talk about how they measure ductility. So it's really a ductility event. And Rove took it and plugged it into some rheology and came up to do some tests at 15 degrees at 0.005 radians and came up with this cracking, this opportunity to predict cracking, intermediate cracking. And then we have non-loaded cracking here, and we have the R value that's come out of a Christensen model. So what are we looking for here? You know, if I'm probably a supplier, contractor, I'm looking for something that guides me and tell me, hey, this number. So there's some numbers. I'll call them the magical, today's magical number. Okay, so aging, we have to think about that too. So the four physical things I like to talk about here is first they're thinking about could we have one thing that tells, at least from the binder point of view, that we could say, hey, this is this number. So we have some numbers anyway. We have some numbers for the R value that came up of Christensen and Anderson. It's a rheological model. And I'll just say those numbers, if you are within 2.5, and it has to do with the cracking, you know, at low temperature and aging, okay? And then we have the delta TC. I think I've heard about that. The delta TC, you can see here, is it's a difference between a critical temperature for the stiffness and the M value. So you measure these and you look at them and you come to a different. I'll give you some examples of that. The crossover modulus is a little shadowy. People are thinking of phase angles also. And so do we need all four is what the proposition is saying, what people are working on. And so can we come up with one parameter to do this? So let's talk about this one, the delta TC MSCR relation to modification. I'm going to make the first caveat here. I talk about asphalt being ductile going to brittle. We talk about modification. There was no modification. and there was modification with SBS, if you like. That was the traditional modifier. There are other modifiers and so forth. And all the modifier does is increase the modulus, stiffens the material, right? And if you're not careful, some of them may even change the bottom temperature of the asphalt. But so what you have, this critical temperature, when you reach these particular numbers, you want to see what those differences are. What's the magical number? So what we have for this delta C being if it's, and the delta C is actually measured in the thermal cracking of the binder, okay? So, and it's a specification that could be 2.5. The best today, they agree, it's not a consensus number, and it depends. Some agencies may say that, they take some recommendations, and one of them today is -5 degrees C. So if you had something like -6 when you did that measurement between the stiffness, the critical temperature for the stiffness and the M value, if you got something lower, you say, hey, that's not a good thing. It's going to crack. That's what's going to happen to that thing. But I started to say, when we modify, I'm going to show you, when we modify beyond certain amount, this doesn't hold. They got not shown this yet, but I will bring that caveat up in a moment. So you have, in general, we have S-control binders, we have M-control binders. In general, S-control binders are not heavily modified and so forth, so on. So I don't know, some agencies have taken -5 to use as a guide, right? As a guide. And let's see what we have. I mean, example of this 6422. It's a neat asphalt. So that's a T of -3.6. And 3% polymer, 3.9. With 7.5, no, it's 7.5. So we have -7. Now, the general, it's not a consensus, is that at the -5 is not very good. So, -4 is better than -5. So this is not very good, but this performs in the field. It's like anything else, right? This performs in the field. So, and we'll go through that in a minute. What's behind all this? Again, I said the agencies, some agencies say, okay, let's use -5, and they can, can play with that number. But what about the Glover Rho parameter? It has been considered as a surrogate, but there's no consensus. The debate ongoing with this, right? And it's all based on some rheological transposition. And I have a reference there if you want to look that up. All right. Let's talk to this modification here. The base asphalt, you do fluorescence, and we have all these tools that we can look at 2%. If we do see polymer, it's a typical SBS, polymer in asphalt, okay? And as you progress here to the continuous phase, the continuous phase being the asphalt, right? And as you go up past 5-6% higher, you get a phase inversion. The continuous phase is now polymer. Okay, it's not asphalt. Let me say something about the people who do aging and asphalt. So if you did some aging and asphalt, in fact, the polymer can mask the aging of the asphalt. Just telling you that. And so we have this phase inversion. So those parameters generally are measuring the rheology of the continuous phase, in that case, the asphalt. So that's just for people thinking about what's happening. And why am I bringing this up? Because I think one or two SBS manufacturers come up with polymers, new polymers. I played with some of them. They're still SBS, but they're talking about the conformation that make them easy to go in, doesn't make it very viscous, and so forth and so on. So you have that situation of about making thinner pavements and so forth. But again, the rules for looking at the rheology is you got to be careful. They probably need to be benchmarked again if the industry is going to grow in the direction of increasing polymer content, right? And so some of these modifiers, you're very familiar with traditional inorganic oligomer, refer to that as PPS, polyphosphoric acid, has been used. And I don't know if edible oil is very popular. At one time it used to be. People are playing around with plastic. But you know, the chemistry of and the asphalt changes has components that makes it easy for certain type of materials to go in there, you know. Well, high density polypropylene and linear low density propylene and so forth and so on. PET from the Coke bottles, you know, you can use those. But again, there's always a compatibility between the asphalt you use and the ingredients you're putting in, right? And ground tire rubber, again, that's seen. And these, again, without going into details, there's several technologies. Either it could be done at a plant where they put it in, like put it in with a polymer. In the case of California, they use other agents to make it easy to go into the material. They used to use gilsonite, by the way, many years ago, but this gilsonite can make your bottom temperature go back, so to speak. It's a drilling fluid, but again, and over here, the more non-traditional stuff. I work with some soybean derivative, which are SBS-like. They increase the modulus, but not there yet. But it's some of it is commercial. So out of the Iowa State University, have done some of that work, and some of that is commercial. They have pilot plants that are doing this. And so what are the benefits for this? Well, the benefits is we're talking about it's environmental and that kind of thing. All right. So, and of course, we have anti-stripping agents, and those can also be biomaterials, right? Now, balance design, mixed design. This is the first definition that came out, and you want to get performance of your road, but every user or every region have its distresses. So I understand there's no national criteria of balanced design. Nobody's going to say, hey, you got to do this. That's not understanding as I understand last week. So there's the AASHTO specification, which is 4622. And this standard practice of balanced design is about probably going to go to ballot. It's to replace the PP 105, which I believe is, you probably can correct me, but I think we had the A, B, C, D. I mean, now it's going to be a little different. And when I say different, it's really, if you're doing your performance, you can start out with a fundamental thing, and then you progress. But every time you move into more tests, it's más dinero, more money, right? So I guess you got to think about what you're doing. It's not just testing and to get well, of course, the best performance, but so you need to balance all that. And what are we doing here? We don't want to move. We don't want to move. We don't what? I don't know what happened. Anyway, this balance design. So they have now tier 1, tier 2. That's going for a ballot, I believe, for this fall. And so I talked about this before in balancing one and the ABCD structure, in that each agency, like for example, I have Virginia as an example here. They're using the APA. Some people are using the Hamburg we're tracking. So Louisiana, everybody's doing their thing, semicircular. So my question is, from outside, I'm looking, why it's asphalt? Yes, it's different in certain area. Why, when we have a standard, is cracking very different in Louisiana? It's about aging, I said. It's about aging, right? So if I don't do a proper aging, doesn't matter where it is. I ain't gonna, would come up with a correct test, so to speak. So I think I'm gonna try the computer. Well, so, yeah, it's freezing.
Two, maybe.
What? Yeah, don't know what. Anyway, so you'll find that some of the agency should identify if its distress is fatigue, cracking, then it will address that. But it want to keep in balance with that triangle. It want to keep its rotting and that and the other things in play. Yeah, it's working. It's working fine. Illinois is have the flexibility test. I've seen some box around here for that, and wheel tracking. This is what they're saying. So we have a series of it's addressing the performance, and you want to reduce volumetrics, right? VMA, voids, and so forth. So as you progress, in your performance testing, and you're looking at asphalt layers, and I guess you're looking at top layers, so to speak, and they want to address climate and that kind of thing. So it's this going to be balloted sometime in August, I guess, this year. So the tier 1 is really the basic baseline. It doesn't say what you do. So they have a long, big table of the constituents, the volumetric, the volumetrics and what you do, and whatever you're going to do. So you look at the big table that's going to be balloted on this. So and so if you go to tier 2, it's like the ABCD type thing. You have greater flexibility. You do less of your volumetric, so to speak. Of course, you get a little bit more expensive. You need to train people. And I guess you need to say, do I need to do this? Can I address this distress without kind of following along those lines? It doesn't mean everybody's going to get there. So to minimize here in tier 3, it's kind of like what you had the ABCDE, volumetric requirement and focusing. Notice I'm saying, and the mechanical testing, validating mix performance. Here I would put in myself, and we've come here at the latter part of my talk, is why are not we looking at the chemical? Why are we not? We have no tools. They're portable tools, and they're easy to do. But we'll mention that as we go down here and in the presentation. So this performance test, I'll just list the longest list is for cracking. You can see as we go down the line here, you see the indirect test. The one that's very popular is obviously that first one. I go to visiting some users, and that's what I see, that this is very popular, all right? So flexibility, Illinois flexibility, the semicircular test, and so forth. And see, look at no, these are all cracking tests. All cracking tests. And I want to show you one that I think it's unique. It's a PBR, and the University of Utah is doing the Pedro Romero. AASHTO as a provisional 125. And basically, I looked at it myself. And it's an instrument made by Canon, but Canon does not make this anymore. And really, it's a baby R, and they're putting a 1 kilogram load on the material. And I like that because then you can drive the weight up, and you can hear I literally hear the material crack. I had a material with 30% wrap in it, but the other person had that at the University of Utah has that kind of material, equipment, I should say. Here is look at all the cracking tests that we have. Mixture performance, yeah. And this is the newest this with Amit Basin. I talked with him. This is TP-150. This is newest coming out this August. Poker chip test, asphalt test. Okay. So anyway, simplified. This is Richard Kim, I guess. Richard Kim. I very little use, I should say. And this ideal test is a surrogate for these guys, surrogate for this over there test. And what we have to do moisture. So I don't know who's doing Cantabria test, but I think Virginia is doing a Cantabria test, determine abrasion of compacted materials. And there's one here, supposed to use a surrogate for the Hamburg test. This guy here, rod-in high temperature indirect tensile test. How many people have done this particular test? Okay, so, and probably as I walk out the room, there'll probably be a new one. Anyway, pavement preservation started back as officially in the legislation of the US, passed a bill back in 2012, right? So we're 13 years, and the mantra was right pavement, right? You need your right pavement, apply the right treatment, right time. And I said, I would add here, well-trained people to do this now. And so this curve came out from the Federal Highway Administration back then, right? And what you see if you build a pavement 20 years and just left it alone, it would decay away like anything else. Age goes down, right? So, but what happened is budgets were being, we need this budget for maintenance. The budget, the maintenance would have a budget. We needed to switch it over here. So I'm sure the three areas that these things should be supposedly budgeted, and I don't work in the agency. So, but anyway, this was so if you don't do anything, you'll end up in what I call the rehabilitation zone, right? All right. So, and if you did not do anything, you have to really overbuild the road. So it costs you less to maintain your pavement, like going to the dentist, going to the doctor. It's apparently common sense. But anyway, so, and you can see you spend a lot of money back here. So that was the extend the pavement life. And I think we're still in that cycle. If user agencies should have a pavement preservation group, which would be substructure of the pavement management group. And so that's my curve. I put polymer modified stuff that would prolong. So if you put some more money and make a modified material, maybe your maintenance will be deferred for a while. That's just me. I can do that at my point in life, be a poet on that. So modified asphalt I have here. All right. Preservation. What are all the different things? I know you guys are getting into emulsions. So I just think all the things that exist, and I know a lot of these things are being improved. The surface treatment, and your pavement has to be functionally, can't be structurally well. Don't do a pavement that looks as cracked, but it's cracked from the bottom, but you just fill it with crack seal and you think it's going to last. So you need to know that the pavement is in good condition so you can do this. And there was a lot of debate at the beginning. What should people saying, these are preservation treatment. And there was a lot of debate in the AEMA, ESA, and ARA about this, because in those organizations, they're contractors and then they're suppliers. I have a relative cost. Crack sealant is the cheapest. I put it at 1. You see fog seal, 1.25, tack coat, 1, and so forth. Slurry, 5 and 2, microserpent, 6 and 7, Cape seal, 7, scrub seal. Scrub seal is literally scrubbed, broom the road. It's a polymer, an emulsion, highly modified. They go and they try to get cracks and so forth and sweep it in, scrub it, so to speak. And there's this, note that this is, so eventually the concrete industry got into pavement preservation. There's a lot of resistance from the concrete industry at that time. But they're in here, you can see what, okay. And structural stuff, we have here coal mix, asphalt, coal in place recycling, 4-inch down, 5-inch down. So it's not considered a preservation treatment. Coal central planet and so forth. And I think this is an increase on some of these coal in place recycling, right? And so the user have to make a decision that based on their budget, all right, and how they want to manage their group. Let's talk about quality. So we talk about quality. So we talk about portable infrared spectroscopy. Infrared spectroscopy is not new to the industry. It's been used in the laboratory to look at, in particular, when the asphalt starts to travel from ductile to brittle, okay? And there's a signal, and they saw that signal is associated when they go and test the viscosity of that asphalt, how it flows, it was harder to flow. It had a greater viscosity, all right? So there's a correlation between that spectra and the infrared. And I don't want to give it a particular name, we say carbonyl, but think of it as a signal. It's really a signal that increases as the thing changes. And so there's a standard that I had, a provisional standard in AASHTO using the portable infrared. I'll show how we got that. That recently became approved as a standard. It'll be published AASHTO T420 to be published this August. And let's see where we go with that. Okay, so this is the work that was done. This is the old, this was weighed 7 pounds, this infrared, portable infrared. That's the exoscope made by Agilent. And then they came up with a new second generation, this blue one. And here's my coworker measuring in pavement. This is all done, work was done in Idaho. This was sponsored by the Idaho Transportation Department. And so I used the first time using a portable infrared to look at detection of, look at the plant. One had wrap. So the purpose of this was to look at wrap in the mix. Take the portable, look at it. Of course, we have calibrated, and we're going through all that. So we did take the approved mix design and spiked it with 0 wrap to 100% wrap. We got those signals, and those are the things that were used to go up to follow this. So we had, note that this was a nighttime pavement. Why am I mentioning nighttime pavement? Well, we worked in the daytime, so we went to collect sample at the hot mix plant. We're going to see it age, right? So those are the things you got to plan and that kind of thing. So anyway, the essence of that standard is you have approved mix design, and then you get your job mix formula, which is the one that you use out on the plant. So that there's a fingerprint of that. There's a fingerprint while the plant is producing. We take samples right out there at the plant. And when the in place pavement, we also take a signal of that plant, okay? It's a non-destructive, it's called diffuse reflectance of infrared, diffuse reflectance. So you see that one of the plant we had, there was a problem, okay? So problem, okay. So anyway, we had over fall, the way we did this very quickly is we, just like they do density in the pavement, randomly picked the surface. We took 5 measurements here, 5 over there, and so forth, and those were averaged to make the repeatability, that kind of thing. So all the pavements remain within 1 standard deviation, and in general, the plant signals, but they were within compliance. This is not a spec, by the way, but it's just showing that the infrared. So think of it. Who are the stakeholders here? It's the materials engineer. I would say the materials engineer like this part, and the pavement engineer likes this part, because the following year you can go and look at it and see what it. agreed it's on the surface. We look at that pavement, okay? So it can look at that. If you tell a pavement engineer, management engineer that, hey, I can predict cracking, he'll hug you, he'll love you, or he can predict cracking, right? Which is the thing you're trying to do on the material side. Yeah. So that's the essence of that. The standard method, again, the provisional 128, 2022. Now it's going to be the new standard. And this was the report, Idaho report, report 249. Yeah. Back then, looking at wrap in a mix. That was the purpose of that project. So, process, we're talking about process innovation now. What I mean by process innovation, if I'm able to integrate things and make a workflow increase with productivity, which under safety and that kind of thing, I should then up for that. So I have this abbreviation of MBA, PIRS, DSR. You know what the DSR is? A moisture balance analyzer and the portable infrared spectroscopy. And what we want to show here, this process innovation of this. This is the moisture balance analyzer. And what we're showing is a recovery of an emulsion in the mold of a DSR. Yeah. And then once that's recovered, I'll show this again. You can measure this in the DSR, and we're talking about the upper PG of the emulsified asphalt, of the residue. Yeah. And then what I've integrated this is another technology, it's a portable. Well, we have these tools. We have these tools. So would it be nice? In fact, I was talking to David at the Oklahoma DOT yesterday and said, hey, I've had binders from they were doing, what were they doing? I think Delta TC. They had the same PG grade, but they had different Delta TC, and that only can be due to oxidation of some type. Anyway, but if you had the portable, then you'll be able to tell something about that. Yeah, this is the portable. So basically, what I'm showing here, the way we use it in what we call a diffuse reflection mode, you calibrate point at the pavement, shoot. There's an accessory. You can take that accessory off and you put what we call an attenuated total reflectance, which is the way most people use this portable instrument. And that's what you see. You place asphalt on this surface here. It's uranium diamond surface, I think it is, and you immediately get the spec. The traditional way in the laboratory is to put the asphalt in a solution, and you make sure you don't have it too concentrated, otherwise you're not going to see anything. Okay, so. But these are all things that kind of well known. The background to this is there's a standard at ASTM for the moisture balance analyzer. Okay, so there's a number of the standard. We did a comparison of that. If you look at the standard 7404, then embedded in that standard at the bottom, there's a diagram which I'll show here. Shortly to showing the comparison between the method one of the methods that's used right now. So what we have butted onto this is the PRS as a conceptual thing. So now they're all kind of moisture analyzer over there. So I had the University of Texas, Amit Bassin. I said, why don't you do this? I'll get an equipment for you. He got an equipment, and he did it his way, however he wanted it. He wanted to show that this is easy, it can be done. And so, this is the one that we generated a few years ago, showing the residue by evaporation. This is the oven. Remember, the oven is right. If I'm not mistaken. Heavy peach, got to equip it, right? And the moisture balance analyzer is a little instrument right here. It's automated. You place your sample. You come back when it's done. You can set it for what percent you want, 0.1%, 0.01%. And so So that's in the standard. And here is where you're going through the step here. You can see the weight, you know, that you see this, right? Now, emulsion sample, your mold of the DSR, silicone mold, and no, you would do this again? Oh, good. Anyway, that's what you've recovered, enough to put in the DSR, put it in the DSR, residue DSR. This is not a standard. This would be something that we would do into the practice. This is what we're doing in a procedure, right? We get it from the moisture balance and the amount of residue. We report it. Your contract gets paid. You read the right amount because it's a paid factor. And we'll do that. But then what we would say, and so I'm just showing you again, right? Repetition, and that's it. That's it. Okay. This was done at 160 degrees for non-modified. We didn't do a lot of modified, but that work can be done with your modified material at 100 degrees. There's a big debate when people do distillation. If they're doing polymer modified, there's a lot of debate about, oh, we're destroying the polymer, it's not the one going to the road. So that's all down to it. Okay, so this is what Texas, University of Texas did. You see, and the way they did it, they first recovered in this. So it's what I call a two-step process, and then put in the mold of DSR. And everything is fine. What I had them do, I contacted the plant to get the emulsion, but I said, before you send us an emulsion, send us the asphalt that will be emulsified. And in the paper that's probably show those results of the modified of the asphalt, the original asphalt, and then they got the asphalt that was emulsified. And those numbers are within, I don't know, 5% of each other, okay? Because there's a concern, oh, you may burn this, oxidize, but those things can all be sorted out because my portable infrared serves as an internal control. Hey, let me look at this guy. Did we cook it too much? And that's not going to happen. You can control these things. So, but you have internal verification of the process. And here's a comment from my good friend Alan in Minnesota DOT. Minnesota DOT is using the moisture balance analyzer in the way they're saying. And let me kind of read what they're saying. We're using the moisture balance some to receive that code, all kind of emulsions, and it's helpful guide to us to expect residue content from the distillation. They do distillate, but they don't want to repeat this because sometimes it's not ready to be done. So, for example, when a sample is submitted, a stack shows a 30% residue on the NBA moisture balance analyzer, and it was expected to be around 42%. We can start checking with the inspector before we even get to running the distillation to see why the residue is off. In general, we have seen results that match up well with the distillation, but because we're not using the moisture balance result for acceptance, we have not looked into the trends or discrepancies. I would expect to have some differences depending on the product because the variation in product along the conditions used for this method. We have not adopted it for spec compliance as the distillation is still needed for residue testing. Though we did try a few samples several years ago using silicone mold for DSR testing. We are currently using a cellulose pad. That's what they're doing, cellulose pad for sample distribution to Japan. So anyway, and you see, you had several people independently look at this, and the process innovation again is bringing three technologies that two of them are widely used. All right, in the asphalt internet, they're used somewhat. The portable. I do know I did a survey with AASHTO. And who has the portable, I think about 5 or 6. I know Maine has, Tennessee has, Alabama has. I don't know exactly. Virginia has, Minnesota has. So there are a few around. How they're using it exactly, I could do it, maybe another survey and see how they do, but they weren't using it. The way they were using it is to use the ATR, attenuated total reflection. I know the diffuse reflection is a little tricky. Anyway, Louisiana, I forget, my friend Dr. Wasi he's done some work. Went down there and he bought, when he called me, he said, I bought one. Oh, I'll come and train you. And so anyway, he bought one, but I didn't discuss that here. I took it off. I think it would have been too long. I think the second step that he's done, he's recovered RAP in the field, but he's doing destructive testing. But I think what he's done to me is very good, because he's able to go in the field and in 8 minutes, I've seen this, extract the binder. It's a micro extraction in the field. Okay. And he injects it and he has the infrared right there. It sticks it on the ATR, attenuated total reflectance, and he measured it. And they have we have some papers on this. So, we're looking maybe forward to getting this out to AASHTO. First is the practice, and then the measurements, right? The same thing would happen here. Is the practice to take it to the DSR, the moisture balance on it to DSR, and then to do with the infrared. So I'll just, the conclusion of this is that this integrated approach is less time, right? It's better accuracy. You don't have to be watching an oven or watching a distillation which has a flame on it, for example, right? Small footprint, you're going to save. If you had ovens, there's some residue recovery where you spread the sample down. I think they're experimenting on that right now, a film, and leave it for 24 hours at 25 degrees. I don't know. In the emulsion industry, it's 15% of the entire industry, I see. And I think if you have to spend a lot of time and even if it's accurate and expensive equipment, then, I don't know, that's something you have to think about. Anyway, so I think that they have one that's involved vacuum at low temperature. The vacuum too, so now you need to maintain a vacuum. Vacuums are tricky. And you need to have the oven in condition. So you talked about maintenance costs. So you should look at this as a quality control tool, clean up in terms of lowering your maintenance cost while getting the accuracy you need. And so, again, maybe we start with this magical pyramid. I would call it the pavement technology pyramid, and the resistance and the things that you need to balance in this industry with all the tests that you need to do. I think, and then we talk about this other thing about integrated process innovation that includes your workflow in quality. So we talk about quality. And I think here, when we talk about the infrared, we talk about the infrared as being, you're now not only going to have the material, the rheological. Granted, rheology is driven by some type of chemistry, but it forms structures that it's impossible to get from the chemistry, as you do quantum mechanics. Anyway, so then, but if you have a fingerprint, just like the FBI fingerprint here, if I have a broken bone, what do I do, right? So I think this integration process, we can integrate this. And I would say if we come now, I'm going to take this over to the balance mix design. The people doing the balance design it doesn't hurt to fingerprint the material. It takes, how many seconds? About 20 scans a second, Understand this work, you should put in an Excel sheet and you have a fingerprint of that, So you know something about the age when you put it in or whatever you're doing, that kind of thing. So it's a powerful tool. That's all equipment. And so I have for all these, there are references in the back for all these things, okay? And I want to thank you having the patience to listen to me going through this tour de force of Asphalt. And thank you very much. I much appreciate it.
We have people online, so I think why not we open, let me ask to give an
Sure.
opportunity to those people first. Anyone, I don't know whether you all can hear me or not. I'm kind of close to the microphone now.
They haven't added any questions yet.
Okay, so you have not added any questions. So maybe what we will do in the interest of time, so I think I know there are, questions perhaps, from the people who are here in person, and while you think about your question. So this is a very complex field, as you have indicated, it's a lot of chemistry, but whether we include chemistry or we exclude chemistry, it's there. So I think I would be in favor of understanding the role of chemistry in what you just mentioned. So with that, I think I would like to actually open the floor for questions here, and then those online, could you kindly also maybe pose your questions on the chat box so that Olivia could actually read your questions? That might be a little bit more efficient. So with that, I think why not we ask the people here to ask questions. I know I have some questions, and Ken and Rasik and others, you may have some questions too. Yeah.
I have one question about
Yeah.
the portable infrared
Yes.
spectroscopy. So you're talking about the fingerprint. So how that fingerprint is going to work? Or will there be any like specific limit? For example, the carbonyl index or the sulfoxide. Will there be any specific limit? Okay, if it is more than this, then it is bad, or it's going to be bad. Or do you think like it is more like a comparison type work? For example, we have to do the initial like virgin material test first, and then we have to compare as we go, as the pavement age.
So the question is actually Dr. Syed Ashikal is asking about the limits in this fingerprint. I think that's a very good question.
Yeah.
So what would be your answer?
I think this is an integrated approach. So what would happen, you would have for that particular binder, you would have a signal, and I use at 1700, we calibrate that particular signal. And if we have no other thing to go by. Now, if we get something for that refinery again, it could be the same PG as I've heard an example, and it could have a different agent profile. You don't see that in the rheology immediately. So what I'm saying is that only by having this data available, then you're able to then come up with something to do this. Yeah, and not by itself. The way I showed it is a quality control tool, right? In the field, we calibrated something and we followed it. Now, if we integrate this with emulsion, we get an important piece of information, because this pavement is going to be laid down. But I will have some profile about it, and I'm sure that I'll get some chip seal. I'll use chip seal as an example, residue recovery, that from two different suppliers. I'm just speculating here. Would it be exactly the same? I don't know that, but it could be. You can create an index, right? I'll go use that in terms of the pavement. With the work that we did, looking at pavement in the field, is you can create an index, all right? Let's say 0 to 10. I can draw a curve. Is the pavement, do I wait till it cracks? Now, you would work in conjunction with the pavement management group, who goes out, and every year they measure it. By the way, permit me to also measure it. I want to know where that's at. And I'm not going to tell him don't do that, but when it cracks, I would think there's a signal associated with that crack.
So basically, there is no, there's some, what if I summarize what you said, that index need to be developed.
Yeah.
So I sort of see this like, for example, if you have a broken bone, how do you know that you have a broken bone? You take X-ray and see whether something is broken or not. I sort of see sort of a parallel in this type of thing. This is an interesting
Yeah.
concept that need to be looked into, and perhaps the same type of answer should be that the limit for the city index, the different duties, they now have limits, and of course it varies from one duty to another duty. Next question.
Yes.
Yes, Sarita.
Since the pavement is always evolving and we have all this technology in place. Okay, I need to be loud.
Yeah, no.
I'll reiterate your question.
Okay. So with all this technology in place, how can this help in the climate changing scenario?
So the question Khalida is asking that how is this integrated process of the technology could actually also address, different climate. So as you know that, US, United States and other countries, are divided,
Right.
and climate is very integrated part of pavement design.
Mm-hmm.
And then you cannot separate it, right? So a pavement in Idaho
Yes.
maybe will have to be designed differently in Norman, Oklahoma. That's a good question.
Yes. Very good question.
Yeah. So how would you address that?
Yeah, I guess, I don't know that the infrared. I'll take a hot zone, Arizona.
Arizona.
Okay. It's a way temperature is increasing, right? So if I have this tool I've been using, I would see that my pavement is being oxidized.
Yeah.
So I would
correlate.
correlate that with that. I'll give you an even better example, the Andean region. Pavement there age, but no, that's not been looked at. I guess we could take Colorado as a possibility of that, 4,000 meters up. So you can see it when I was in the equator, you could see those pavement very, very quickly aging. But they're subjected to strong UV, much stronger UV.
Yeah.
It's probably the place where I think you may see the greatest climate effect first, maybe, than in this
So
area.
yeah, UV is one of them, but as you know that
Yeah.
also during production of asphalt mixes,
Yeah.
you also have aging. That is
Uh-huh.
not necessarily UV related.
Right.
But I think the bottom line is that aging could be one of the factors.
Uh-huh.
A pavement in
Yes.
Arizona would age very
Yeah.
differently than the same pavement
Yeah.
in another location. So that is another thing that
Right.
we could see.
Yeah.
But in addition to aging, anything else that any other parameter that you may be able to identify based on different climates?
Based on different climates. No, I can't think of anything on that,
So,
Yeah.
so what, next question. Ken, you don't have any questions?
Well, I'm wondering, you might want to look at binder source variances.
Yeah.
It's not uncommon to switch binder sources. if
Yeah.
there's a problem.
Mm.
This tool might be able to look at that.
Mhm.
So, change in binder source,
Mhm.
would it affect the fatigue without
Yeah.
going down that road?
Exactly. So,
Yeah.
Ken actually
Uh-huh.
asked a question regarding binder sources, and that's very true that.
Oh, yeah.
Right?
Yes. That's
You
real.
cannot get all your
Right.
binder from one source, right? So
Mhm.
that's a very, very good question. So naturally,
Yeah, well, the studies have been done, or the research have been done, they don't integrate that part because,
yeah,
people are not thinking in terms of that. Because I guess before Sharp, chemistry, well, but I'm saying this portable was just came around a few years ago, FDIR has been around. So if now it doesn't cost much to spot a spot on whatever it is, when it cracks, is it associated with what you did when you age it? In fact, one example would be RTF oven. If you take samples out, so what this is pavement, so asphalt is going to lay the pavement now with that asphalt. So you take samples out, you'll see the signal, and what you would do now, okay, so that's going to go from mix design, so forth and so on, right? I'll finish quickly here. And so you'll have the signal for all that agent material. And now you will relate it to the field once the pavement is laid down.
Yeah,
And
absolutely.
you go and spot, hey, this is, look what happened. So we don't have that data. But
Right.
that's the experiment to be
Yeah,
done.
or any question online? So I think, let me also ask something that's really important to balance this design and, what we do in Oklahoma, I'm pretty sure, in other states also. You talked about RAP, right? So RAP, is reclaimed asphalt pavement, is a recycled material. I think both from the state DOT side and also from the industry side, they love it, right? Because it's recycling, it reduces cost.
Mhm.
And so I think this is beneficial. The RAP quality is a big question. Most of these DOTs are asking that I'm using this RAP and you want to increase more and more,
Mm.
but how about the quality? So I think one of the things that you pointed to is that if you have this fingerprint, I'm using this word fingerprint, it's a kind of a good terminology for different RAP. And then if you are able to establish this limit that you're talking about, Rashid, that range of the thing,
Mhm.
and aging, of course, aging is a big factor. Of course, there are other factors too, but aging is a very big factor,
Mhm.
right? So maybe that's something that you may want to amplify
Sure.
in terms of actually could this integrated
Mhm.
process, and you talked about,
Yeah.
infrared spectroscopy, be used, to quantify. One of the problems in asphalt that we have difficulty in quantifying. The previously, how people would know which the asphalt binder, I was told by Dr. Laguras that they would put it in their mouth and they will sort of feel it and see how easy to chew. Please don't chew it,
I,
So I think that's what Dr. Laguras has told us,
yes.
right? So you have to look at from there and where we are now. It's a very, very big difference, very big difference. So that is one thing that
Yes.
you may want to actually also
Sure.
see that how this type of technology, and you talk about, we know that in construction time is money, right, Wes? So if you can actually reduce construction time, instead of penalizing your contractors, if you can
Mhm.
have a process whereby they can use this type of technology to actually give them benefit, give them bonus for what they're doing. We all need good quality work, right? I don't know anybody who does not. So maybe this is another thing,
Yes.
Delmar, that
Mhm.
this technology could be, of course, assuming that the cost will come
Yeah.
down. But
Oh, yeah, definitely.
equipment cost is a big factor for,
It's a quality tool. It's a quality tool.
yeah. So maybe that's the biggest benefit I can sort of see, one of the biggest benefits. My last statement would be, the chemistry is really inherent in asphalt. You cannot separate it. Unfortunately, I did not take any chemistry as a course as a graduate student. It's too late for me now. But those of you who are working in this area, please understand that chemistry is there. So it's better to accept it and it's better to actually address it. That way then your product will be better. That's given for sure. And let's give a big hand to our speaker one more time.
Thank you. Thank you.
And I want to thank all of you for being here.
Mm.
I was telling you that this is the week after the final exam.
Yes.
So this is not
So-
a good time for us. And
Ah,
I want to
yeah, spring
thank,
break.
we also want to thank all of those who are online. Please, any topic that you want to see in future, we will try our best to actually bring it to you. Those of you who need PDH, that's free. We're not going to charge you money. PDH, you'll be getting a PDH, 1 hour PDH from this event. Also, we're going to put this presentation and the lecture also. Katie,
Yes.
will be, posted on our website. So if you have any questions, and I would presume,
Yeah,
Delmar,
yeah.
that they can contact
Right,
you.
right. Yes.
Uh,
Email is there.
Email is there, so please do that. So we greatly appreciate, and we hope to see you all again. That's what we do at
Thank you.
SPTC. Thank you all.
Thank you. Thank you, Olivia, for all this. Thank you.
Thank you for
Thank you.
putting up with any
No, no.
technical difficulties.
Okay. Very good job.
It's a different topic.